Hello, welcome to another video. Today we'll be deriving the basic equations of statics. So as you can see here, we have a small little cube that is within a system. So I'm gonna give the cube some variables, and I've already given it to the cube, so I'll just read them off and describe them. So z is the height. So we have the dz is the change in height. Pz times area will be the pressure times the area. And then, so that'll be for the bottom. Then we'll have dz plus z, that'll be the top area. And it'll also be the change in height taken into account there. And area is A, so now let's get started from there. So we have the force equation, F equals ma, and A will equal 0. Then we have the change in force equals 0. Change in force equals Pz times A minus Pd z plus z times A minus mg equals 0. So that's going to be our equation that we will derive. I'm going to clean it up just a little bit so that it's nice and easy. So we'll get negative A dz pdz plus z minus pz equals mg. And if just a little remembrance that m, mass, equals density times volume, because we'll need that. So here we go. What we're gonna do now is still clean it up. We'll add in the m equals density times volume equation too. So times pdz plus z minus pz equals density times area dz g. And the reason why I got the area times dz is because v equals a dz. And then we'll substitute that in for our mass equation, density times volume. And there we go. So now what we'll do is cancel some of the likely variables out. So the a cancels out there. Clean it up a little. P d z plus z minus p z equals negative density times g times dz. And we'll get it all to one side here, so we'll get p dz plus z minus pz equals negative density times g, all divided by dz. There we go. Let me redo that so it's a little clearer to read. Z, and let me change this to look like density there. There we go. Alrighty. So now we'll calculate the change in height into that equation. So dp over dz equals negative p times mg over rt. And how I got this formula is doing p v equals nRT, the basic ideal gas formula. And we'll also need density equals m times v. And since our mole is 1, that's like a cube there. We'll say that that's equal to n times mv. P over RT. Density equals PM over RT. And there we go. That's how I got this formula for dP over Z. Now this is just part 1, so I'll be right back with part 2. And then we'll have to do part 3, and that's like both the equations kind of plugged in together. Alrighty, so this is part 2. This will be the relationship between temperature and pressure. And this will be using the first law of thermodynamics here. So let me get set up by just writing out the equations that we will need. Actually, let me square the first equation off because we'll come back to that. Okay, so we'll start out with du equals dq minus ppv, with p equals px, dq equals 0, du equals cv dt. So now we'll do a little simplification of this, and well, right now, and then it'll be complexified. du equals negative p dv, cv dt equals negative rt over v dv. Then we'll do the integral for that. So cv integral temperature, because that's going to be like the dependence parameter, sorry. dt over t equals negative r integral d2 d1, that's our second parameter, dv over v. Alrighty, now let's solve for the integral that we were given. So we will get cv times ln t2 over t1, then equals r negative r ln v2 over v1. Alrighty. After that, we're going to simplify a lot. We're going to solve for the ln, natural log, and yeah. So to do that, we'll get t2 over t1 equals v2 over v1 to the negative r over cv. And that will equal t2 over t1 equals t2 times p1 over p2 times t1, all to the power negative r over cv. Then we'll come down here and we'll get t2 over t1 to the 1 plus r over cv, and also equals p1 over p2 to the negative r over cv. Then we'll kind of combine them both together and get we'll get an equation for t2 in the end. So let's see here. So we'll need a couple parentheses here. T2 over T1 times CV plus R over CV. Another parentheses. CV over CV plus R. And this is also to the power here. That's to the power. Alright. And then that is going to be equal to a couple of parentheses, P1 over P2 to the power R over CV. and then CV over CV plus R. That one looks kind of like a E, so I'm going to erase that. Make it look like a, nope. Make it look like a C. There we go. Alright. Sorry. Now, time to simplify a lot. So we get T2 over T1 equals P1 over P2 to the negative R over CV plus R. And then we could bring the T1 out and get T2 equals and then the equation. T2 equals T1 times P1 over P2 to the power of negative R over CV plus R. And that is going to be our second equation. Now we'll come back and we'll combine the two. Yep. Alrighty, welcome back. This is part 3. And now we will be substituting our two equations that we got from part 1 and part 2. Let me write those down real quick so that we have a good understanding. Let's see here. dP dz. Here we go. And this one. CV plus R. Okay, now what we're going to do is solve for it. What I am going to do first before I start to substitute is I'm going to give the this a variable so that it's easier to write down and I'm not having to write a long list of things. So I'll say, oh, that's bad. Epsilon equals epsilon equals negative R over CV plus R. Okay, now let's get started. So we'll get first equation dP over dz equals negative P, give that a little one, and G over R T1, then multiply that by P2 over P1 times epsilon, and a little simplification, we get equals negative pressure 1 plus E is M times G over R T1 times R E. Alrighty, now it's time to solve for the integral of this equation. So, integral, it's going to be in the parameter pressure, pressure final, pressure initial. P to the negative 1 minus E epsilon dP equals negative mg over RT times P1 to the epsilon. All times ZF ZI, and that will be dz parameter. Okay, now let's solve for the integral here. We're going to end up getting negative 1 over epsilon P to negative epsilon, and then PF over P initial equals negative mg over RT times P1 negative epsilon times ZF minus Z initial. Alrighty, now let's distribute the P final, P initial out and subtract it so that we solve for that. Then after that we'll combine them. We'll end up getting an equation for PF, but what we'll do is use that equation in turn to solve for temperature final. Okay. So we get PF negative epsilon minus P negative epsilon equals P1 negative epsilon, not 3 epsilon, and then times epsilon mg over RT1 times ZF minus Z initial. Alrighty. Now what we can do is simplify them more. We'll bring it all to one side so we get that pressure final there. P1 negative epsilon. No. Keep on doing 3 since of epsilon. There we go. Epsilon. Then let me see. So we get that times 1 plus epsilon times mg over RT1 times ZF minus ZI, all of that to the power of negative 1 over epsilon. Alrighty, that looks good. Now let's do a little bit more. Let's get the negative PF to negative epsilon. Let's get that negative epsilon out. So we get PF equals PI times 1 plus epsilon mg over RT1 times ZF minus ZF initial, then to the negative epsilon, the negative 1 over epsilon, sorry. Alrighty, let's clean it up just a little bit. We're gonna put in the negative R time over CV. Is that right? Yeah, negative R over CV plus R. We're gonna substitute that in for epsilon, and it'll clean it up at the end there. So we get PF equals P1 1 minus mg over CV plus R times T initial times ZF minus ZI, and then to the power of CV plus R over R. Alrighty. So now I'm going to continue to work on the temperature final equation. For the temperature final equation, we get TF equals T initial times P over PF. Alrighty. To the epsilon. Now we're going to do TF. We're going to plug in the equation that we had before, that we got right here. This one, that one, and we will get the final temperature there. Hopefully you can see. So we get TF times T initial 1 plus, that was kind of ugly, so I'm going to redo that. 1 plus epsilon mg over RT1 times ZF minus Z1. Okay, now let's just replace the epsilon in that equation with the value that we assigned it above. So Z negative R over CV plus R, I think it was. Let's see. Yeah, this one. Okay, so we'll plug epsilon in, and that will be your temperature final equation. So TF equals T9 1 minus mg over CV plus R, and then that'll be times temperature initial, and then multiply all that by height final minus height initial. And there we go. That is our equation for temperature final. Thank you for watching. I hope you enjoyed it, and I hope you learned something.